Today we're having our presentations by Gormley, who's a teaching professor in MLD. And there's going to be a couple cool things covered today. One of the really important things is that there's sometimes a misnomer, I think, that when you get your PhD, that there's like basically two paths. And one of them is to either become like a tenure-track faculty or to go to one of three companies. You may be surprised to learn that people get their PhDs and they do lots of other things which are incredibly useful. For example, maybe teaching one of the largest courses that we offer at CMU. And so in terms of actually having impact on like a substantial number of people's lives, and both, still being able to do some research if you want to, but then also being able to really like actually affect the next generation of people. This is a very cool other life path, and so a kind of role model that you might be interested in. And so Matt's going to talk to us about a few different things, but I will let him take it from there.
Thanks. So this is going to be a weird talk. I have never in my life given a talk anything like this before. So you all are in for a bit of an experiment here. And got it. And I think that part of the fun here is that it's not often the case that there's opportunities to sort of give talks both about teaching and research. And so today we're going to talk about both. And to get started, I wanted to talk about Goldenrod and Aster. And so in particular, I want you all to just appreciate for a minute the fact that I took this picture. Yeah, this is actually in my backyard. My wife planted the Goldenrod and Aster here, and something about it is just beautiful. But don't take my word for it. In fact, you should probably more aptly take the word of Robin Wall Kimmerer, an actual botanist, who's thought about this a lot. And she writes, if a fountain could jet bouquets of chrome yellow and dazzling arches of chrysanthemum fireworks, that would be Canada goldenrod. Each 3-foot stem is a geyser of tiny gold daisies, ladylike in miniature, exuberant in masses. Where the soil is damp enough, they stand side by side with their perfect counterpart, New England asters. Not the pale domestic, oh, here she actually kind of goes on this little, it's kind of like trash talk on some other flowers. It's a little harsh. I'm going to skip that. Alone, each is a botanical superlative. Together, the visual effect is stunning. Purple and gold, the heraldic colors of the king and queen of the meadow, a regal procession in complementary colors. And at the end, she notes, I just wanted to know why. And here she's referring to, why do these two beautiful flowers grow together? And more to the point, why are they so beautiful together? Robin Wall Kimmerer, as it happens, has the title of Distinguished Teaching Professor. She's the director for the Center for Native Peoples and the Environment. She did her PhD in botany, and she's a member of the Citizen Potawatomi Nation, and has written books and all sorts of interesting papers on this stuff. But her start was a little rocky. This is another little bit from that book. This is the moment where she first showed up as a bachelor ready to study botany. And her advisor peered over at me, Robin, over his glasses and said, so why do you want to major in botany? His pencil was poised over the registrar's form. I told him that I chose botany because I wanted to learn about why asters and goldenrod looked so beautiful together. I'm sure I was smiling then in my red plaid shirt, but he was not. He laid down his pencil as if there was no need to record what I had said. Miss Wall, he said, fixing me with a disappointed smile, I must tell you that is not science. That is not at all the sort of thing which botanists concern themselves. but he promised to put me right. I'll enroll you in general botany so that you can learn what it is. And so it began. She goes on in this essay to explain why they are beautiful together. Oh, we have 2 screens. Look at that. This is nice. Let's stand over here. And she gives at least 3 reasons. One of them is anatomy. The retina has 3 different types of cone cell receptors, one that's tuned to blue, one to red, and one to purple. And, one to purple and yellow together. Artists would comment that purple and yellow are complementary colors, and she writes, in composing a palette, putting them together makes each more vivid, right? In biology, we see that it's actually to catch the attention of pollinators. So the real beholder whose eyes they hope to catch is a bee bent on pollination. Bees perceive many flowers different than humans do. As it turns out, though, goldenrod and asters appear very similarly to bee eyes and human eyes. We both think they're beautiful, a beacon for bees. Okay, so here's where we start today with this definition and this picture of mutualism. The idea that growing together, both of these flowers receive more pollinator visits than they would if they were growing alone. And she notes that this question, why are they beautiful together, is a testable hypothesis. It's a question of science, a question of art, and a question of beauty. Why are they beautiful together? Okay, so today I want to basically argue for the mutualism of teaching and research. And in particular, I think we all know that in modern academia, teaching and research sort of have mutually benefited, right? Attracting students to universities where both make a prominent appearance. Okay, I'm not like trying to call you all bees, but I mean, I'm kind of calling you all bees. Anyway, okay, it's a great analogy, right? To drive this point home, I want to start with an excerpt from a conversation I had circa 2015 with my advisor. And my advisor was Jason Eisner, and I had just gotten one of these, and so he said, so what's next? I said, well, I either want to do research or teaching, but definitely not both. Jason replied, I wouldn't want to try one without the other. I said, well, why not? And he replied, well, my research tells me what to teach. And teaching is how I figure out what we've really done and what we need to do next. And then he started talking to himself. When I don't have students to talk to, I have to explain things to myself and answer my own questions. So his picture of why these two were so intimately coupled was that research was actually directing the teaching, and that teaching was actually informing the research. Okay, and he's not the first person to have this idea. This is Richard Feynman, and this is an article about Feynman's lost lecture by David and Judith Goodstein. And David says, once I said to him, Richard Feynman, Dick, explain to me so that I can understand it, why spin 1/2 particles obey Fermi-Dirac statistics. Sizing up his audience perfectly, Feynman said, I'll prepare a freshman lecture on it. But he came back a few days later to say, I couldn't do it. I couldn't reduce it to the freshman level. That means we don't really understand it. I think this is actually like a fundamental idea, right? The idea that if you can't explain something, you probably don't understand it. And this is understood at big companies where they ask engineers to be able to explain things to business people. Sometimes it's because the business people wouldn't understand the complicated explanation, but sometimes it's to get the engineer to prove that they actually understand what they're building. Okay, so there's this question then, how has teaching enabled me to be a better researcher? So I want to offer this anecdote. So the setting here is fall 2019. I was teaching a course called Machine Learning for Structured Data. This is the first time that I had taught it, and it was kind of like an undergrad and master's version of probabilistic graphical models course. And the first homework was on Dagger for recurrent neural nets applied to phoneme recognition on the Timid data set. OK, some background here. Actually, how many of you know Dagger? Or learning to search more generally? Not too many. OK, that's fine. You should take this course. So imitation learning is actually this idea that comes from robotics. The idea is that if you're trying to train a car to drive around a track, the car might actually have some very expensive expert policy. It might be actually a human with a remote control. And when they drive it around the track, it follows this blue line, and it stays on the track. Okay. This red line is what the model policy would do. It would actually sort of drive off the track and crash into the side. And the key idea of Dagger training is that you should actually follow the model policy sometimes, maybe not to the point of driving into the wall, but and collect a sequence of states, but use the expert policy to dictate what action should have been taken at that state. And so in doing so, you collect a whole bunch of data for a multi-class classifier such that you can train the classifier to produce actions that look like your expert policy. OK, so another name for an expert policy in NLP is a dynamic oracle, or in other words, an oracle function that sort of works dynamically, right? So if we were applying Dagger to a problem like dependency parsing, then when you've parsed, with a shift-reduced parser, the first half of the sentence, but you've made an error, there's this question, what is the optimal way to complete that parse? And the dynamic oracle is a dynamic programming algorithm that can try to answer that for you. OK, so the problem was, just before releasing this homework assignment, I realized that, to our knowledge, no one had invented a dynamic oracle needed by Dagger for character error rate, which was the loss function we were using and that anybody would use for something like phoneme recognition. Or sorry, I guess it's phone error rate, but same thing. OK, so this was a problem. But I had a solution. My idea was, let's release the homework anyway and ask the students to figure it out for us. Right? I mean, this is a great research problem. They didn't figure it out. It was a little disappointing. OK, but we figured it out later. Ramon Sanabria, who actually sat upstairs here, and he was a student of Florian Metzi's, we sketched out a dynamic programming algorithm on the whiteboard, and then when we went to publish it, we realized, OK, someone had actually scooped us. You can go read Optimal Completion Distillation for Sequence Learning. They actually didn't realize that what they were doing was Dagger, but it is. So when you read it, just recognize that all they actually did was invent the missing dynamic oracle, which was a great contribution. OK. Not to worry, though, because there were lots of other metrics for which there were no dynamic oracles. And so we invented those instead. OK? This is just a picture of a dynamic oracle for, say, for sequence tagging, where we would evaluate with F1. And so the idea is, given a partial output sequence, what is the completion that minimizes loss with respect to the gold output? OK, so here, at the bottom, we have a sentence, get to the Glasgow Film Festival for Winter's Bone, the movie. And the gold sequence is, begin a location, inside location, begin a creative work, inside a creative work, OK? So this is a named entity recognition task. And so if your model started making these predictions, begin a corporation instead of a location, now you've made this error, and the question is, what is sort of, according to F1, or a chunking F1, what is the optimal completion of this sequence, right? Like, how should we fill in these red boxes optimally in order to reduce our loss function? Okay. Now, this is sort of a funny, the reason that we call it an oracle is because to answer that question, you can actually look at the gold sequence. And for some loss functions, it's very simple. Like F1, it turned out to be very straightforward how to actually exactly compute that completion. We have algorithms, as I mentioned, for dependency parsing already. But for some metrics like blue, as far as I can tell, there does not exist an efficient exact dynamic oracle. So we explored how you could actually build an approximate or greedy dynamic oracle instead. OK. So back to our theme here. How has research enabled me to be a better teacher, right? So I think there's lots of ways. One is connection to real-world applications, right? Like if you aren't actually solving real-world problems, and you're trying to teach a bunch of master's students who are going to go off and solve real-world problems, that seems like a little bit broken, right? So I've had the good fortune of having a bunch of external collaborators who kind of really directly inform with industry partners and nonprofits what the real-world applications are. So another aspect is sort of identifying the limits of the methods that we're working with, right? You can read a lot of paper, but the limits and the negative results are not always going to be there. You actually need to sort of fail in research and identify it correctly as failure to figure out a lot of times what the limits of these techniques are. Maybe also an excitement for building end-to-end working systems. I think, and an appreciation for writing code. So, you all are, most of you in this room are like too young to remember it, but there's a couple people who were around when we didn't have machine learning libraries with like 1,000+ stars on GitHub backed by major corporations. You all have the luxury of using these, but it's possible that the next thing we're going to build is going to be so wildly different from those thousands of lines of code in PyTorch and TensorFlow that you might need to write it from scratch. I think research broadens sort of my love of different methods or exposes me to more of them. And I think another thing is like knowing when to quit teaching a topic, right? Like there's, one of the trickiest decisions in teaching is which topics do you cut out? OK, so another view for this idea of mutualism of teaching and research would be that, OK, and sorry, we had like all these famous people come along and give you their perspective. This is my view. And I think I agree with Jason Eisner and Richard Feynman, but maybe this is the aspect of the mutualism that I think they missed. One is teaching a course twice is research. So anyone in this room who has taught a course twice is like, oh yeah, obviously. But if you haven't, I'll talk about what that means. The second one is advising research is sort of reciprocal teaching. So we'll talk about that too. OK, so teaching a course twice is research. I was trying to remember what the scientific method was. So I went to one of the great sources of knowledge on the internet, Khan Academy, and looked up a middle school biology discussion of the scientific method. You'll remember that it consists of some steps like these, right? Make an observation, ask a question, form a hypothesis, make a prediction, test the prediction, and iterate. I think grossly omitted from our scientific method in NLP is step 7, replicate. Anyway, so I think that for us as teachers, teaching is actually an iterative process. I didn't get that right. Hold on. Teaching is an exploratory process. Still kind of not quite. Teaching is a redundant process? No. Man, I know it's there some. Teaching is a repetitive process. Teaching is a repetitive process. Okay, so here are some anecdotes of the scientific process of teaching from my experience teaching this particular Intro to Machine Learning course, 10.301.601, about 10 times. Here's the first one. The observation that we had was that MLD is teaching exactly the same course twice. A section of 250 students in the morning, and another section of 250 students in the afternoon. Two completely different instructors, two completely distinct sets of TAs doing everything separately. My hypothesis was this is inefficient, and so we tested that by just teaching 500 students altogether. This here is a plot of enrollment. I think I just picked a random year. This is maybe like, I don't know, spring 2019 or something. And I'm not sure why the PDF is all garbled, but on the x-axis here is the number of months relative to the start of classes. And this is enrollment. So this blue line on the top is the Intro ML course I was teaching. And this mark about here, as you can probably guess, is the start of classes. So in case you were ever wondering, am I going to get off the wait list? The answer is like almost always yes for any course, so long as you wait long enough, because they all have this curve where like they drop way down like this. Anyway, okay, now you know. Another anecdote here. So the observation was no one comes to recitations. So one hypothesis was they aren't interactive enough, and a test that we ran was, well, let's make them interactive problem-solving sessions. Another observation was that synthetic data on homeworks is boring, so our hypothesis was that real data sets would better engage the students. And then, you know, this one, I mean, for this room, it's so obvious that that this was true that, you know, we didn't even really think of this as a test. We just made the change, right? You all know that. But in the machine learning department, some people don't always see eye to eye with you on that point. Okay, so in a class of 500 students, no one knows anyone. It's almost more problematic. It's like there's more people, and yet somehow there are less, you know, relationships made in this sort of massive course. And so the hypothesis was students need a social nudge. And so the test that we ran was, well, let's enable collaboration through randomly assigned homework groups, right? Sounds like a good idea. It was an enormous failure. This was like one of the great failures of my teaching career here. So we went back to the drawing board, right? Not all of these ideas work out. So we said, okay, same observation, and same hypothesis, but the test that we ran was different. We instead started a peer tutoring program. And I had this lovely slide where we said, you know, there's like the tutor and the tutee, and the tutee gets better grades, but the tutor probably also gets better grades. Why? Because, you know, the tutee is getting the deeper understanding by being taught, but the tutor is developing mastery of the material, because how do you come to understand something except by teaching it, right? And then also, you know, the tutee was kind of getting personal attention, and it ends up as sort of an improved course for everyone. So we gave it this positive spin, and this was actually a big success. And I think it was not a big success because we tried to spin it as a big success. It was a big success because the fundamental idea, the simple idea of adding more sort of teaching interactions to a course among students was a really effective one. And it worked a lot better than, say, an alternative like just study groups. OK, so another problem. The same three people ask all the questions. Hypothesis, everyone has questions. Test was, why don't we just give points for writing a question in an in-class poll and force everyone to write down a question? Can I do that right now? Probably not. We don't have a Google form set up for that. Anyway, I'm sure you all have questions. And if I forced you to write them down right now, you would ask them, right? OK, so another big mistake that I made early on in teaching was summarized in this teaching philosophy statement that I had to write up for some reappointment or promotion or something. And I wrote something like this. One of my early mistakes as a teacher was to ascribe to the transmission model of teaching, in which my goal was to transmit as many important topics as possible to the students, typically through lectures, and then to assess their knowledge of those topics, typically through homeworks and exams. But in spring 2018, while teaching 10601, I shifted my thinking towards a learning-based model in which my goal was to create a learning environment in which students would take charge of their learning, and I would do everything possible to speed along their progress. OK, so there are some natural consequences of this shift. On the right, I'm kind of showing some analogies to research. They're that the role of the course, is to ask good questions, right? That a good student answers those questions by posing an answer, arguing for it, maybe failing in that argument and trying again, right? And also backward planning is a natural consequence, listing out what the students should be able to do and then developing an environment to get them there. Another way to summarize this philosophy is stay out of the way, right? Some background here. Traditional Inuit parenting relies on storytelling. So think about what parenting without storytelling would be like. It's like, you there, child, put on your hat. With storytelling, though, it's a little different. The northern lights are apt to steal your head for use as a soccer ball if you don't protect it with a hat outdoors. OK. Which of those would you remember as a child, right? OK, so initially, my teaching was kind of dry. Maybe it's that machine learning is sometimes kind of dry. So I tried adding memorable storylines into our discussions of core machine learning topics, right? Instead of just thinking about gradient descent, we would talk about like a nighttime hike going down Franconia Ridge, right? To talk about SGD, I would tell a story about a cell phone in a desert, right? There were sea lions and polar bears, killer whales, and even Totoro made an appearance, right? OK, so I want to take a little bit of an interlude here, just to mention sort of my path to becoming MLD's first teaching track professor. OK. So pre-PhD, I had lots of wonderful mentors. All of my schools were within a 1 hour and 52-minute walk of each other. And then I went and did a PhD, thankfully in a different city. And no, I'm just kidding. I actually love Pittsburgh. It was great. This is all in Pittsburgh. OK. And there again, I had some wonderful mentors. And then I did a job search. And these were the job offers that I got, or at least I think that's it. I don't know. Maybe if there were others, I've forgotten what they are. So there were these research scientist positions that we've already thought about. And then there was this strange position at MLD that was to become a teaching track professor. You'll notice, actually, there's an interesting bit here, which is this owl. He actually did take the job at Duolingo. He's doing that dance because they just went public, and he is now a millionaire. I did not take the job. That's why I'm here talking to you guys instead of sitting on a beach in the Bahamas. But well, you can't have it all. OK, so job comparison. I think this is just kind of useful to see. I almost like skipped making this slide, but I brought it back in the end. So what I'm comparing here is MLD teaching track, tenure track, and research scientist. Okay, so the teaching track, if you have no idea what I'm talking about here, the idea is that you're promoted based on your teaching, whereas in the tenure track, you're promoted based on research and teaching, but in parentheses, I would say. And so that means that teaching is an essential part of being a tenure track professor, but it's maybe not foremost. Both of these have voting rights. The distribution of your time tends to be quite different, though. So, I would say, 75% of my time is teaching, 25% of it is research, and then 25% of it is service. I'm not sure why, on the extreme, that adds up to 150%. But then on the tenure track, you'll notice that these on the extreme add up to 175%. Man, you guys have it rough. So teaching track, there is no tenure. Instead, you're on 3-year appointments and then 5-year appointments. Tenure track, you're on 3 to 5-year appointments for a while, and then you get tenure after 9 years. And MLD, I think all of SCS, is explicit about hiring in order to tenure you, right? It's not like some universities that are, hiring 3 in order to tenure 1. So, I think often the teaching track gets a bad rap because of the fact that there is no tenure. But I want to compare that for a moment with the research scientist position, which is employment at will. Okay, so when a recession hits and you have a research scientist position, you'll just be fired. But if you're a teaching track faculty and the recession hits in the middle of one of your 3 or 5-year appointments, you're totally fine. You just ride the recession out and then everything's good again. Okay, no, that's not, nobody's really laughing. Anyway, so research scientists teach too. So these are some NLP people you might know, Slav Petrov and John De Niro. Slav has done adjunct teaching at NYU while managing a massive team, an NLP team that's been really successful at Google. John De Niro was a research scientist at Google while teaching for 3 years at Berkeley, and then he said, I should just go teach at Berkeley, and so he left Google behind to go be on the teaching track at Berkeley. So I was trying to also think, how can I drive home this picture of sort of this job comparison of teaching and tenure track. So, Graham and I were talking, and I was like, well, maybe I could make a little slide that compares, how many people are reporting to you and how many people are reporting to me. It'll be cute, right? Because what you're going to see is that, I'm doing all these. I have all these teaching reports, and then Graham has all these research reports. So, okay, so I have 1 PhD, and then 4 master's students and an undergrad. Those numbers are actually a little high for me right now. I usually am trying to keep that more at 3 or something. Graham, on the other hand, has 10 PhDs, 2 master's students, 2 postdocs, and a research engineer. Man. Okay, so on the teaching side, right now I have 26 TAs, 3 full-time teaching staff, and about 450 pupils. And Graham has a class of 30. What? 200 students, 10 TAs? Man. Again, the tenure track is hard. You really have to do it all. Man, I do feel bad for Graham. Anyway, you can imagine a cartoonish picture of the tenure track where teaching is not a part of it. But most of many of the most influential mentors for me as a teacher since coming to CMU have been tenure track teaching faculty. Tenure track faculty because they are incredibly invested in their teaching. Right? I'll just mention this. MLD has been an incredibly supportive environment for my family. During the first 5 years, I was on paid parental leave for 2 full semesters. Okay, and then like strongly encouraged by SES faculty to take that leave. Honestly, I think CMU might be one of the only places in the world where you could get that kind of red carpet treatment. I mean, I think it's possible that they might have actually invented the idea of parental leave, now that I think about it. And I don't think it's funny, but anyway, I think it's a wonderful aspect of academia, at least at CMU. Okay, so what about research? So I would say that advising research is sort of reciprocal teaching. To define this, this is a technical term. Reciprocal teaching is an educational technique in which students become the teacher, typically in a small group reading setting. Imagine like a second grader or a first grader who's learning to read, right? So I would say that most of what I've learned since coming to CMU was thanks to my students and research collaborators. So what have I learned since coming here? Rather than giving you like kind of a detailed research talk about any one thing, I thought I would just kind of give you a little sprinkling of some of the things that my students have taught me about. One of those is learning to beam search, right? So I think most of you know what beam search is. It's, fast, greedy inference used all over the place. And the whole idea of learning to beam search is that you want to actually learn to compensate for the approximate heuristic that you're using at test time, right? And so I might have actually been kind of instrumental in coming up with the actual algorithm that we laid out, Renato in particular laid out. But Renato was the key person, and Jeff as well, in actually proving that we actually got these no regret guarantees for the algorithm that we had come up with. He was also then able to phrase that meta-algorithm in such a way that we could draw connections to a bunch of other algorithms that had already appeared in the literature. So neural sample rank. Many of you have used PyTorch or TensorFlow. How many of you have used a Gibbs sampler within PyTorch or TensorFlow? Oh, seriously? Oh, that's awesome. Okay, so one person. I was expecting 0. I'm super excited now. You should tell me like in what context after this. So one of the problems is that generally like a Gibbs sampler isn't just sitting around. You probably had to build it yourself, right? There is no like nn.gibbs sampler module, right?
There's Pyro now.
Ah, yes, that's true.
And TensorFlow probability that implement sampling-based approximate method. Yeah.
Yes.
But it was not there when.
Yeah, and I think this was joint work a couple years ago before they existed. So, and maybe before you did it as well. So building a Gibbs sampler in these libraries is a huge pain because Python is super slow. And so one of the things, I'm not here to talk, so Gibbs sampler, very loosely, if you have like an assignment to a bunch of variables, a Gibbs sampler is picking one of those variables and it's like rolling a die or flipping a coin to like resample the value of that variable, right? And if you do this long enough, you get a sequence of samples from the true probability distribution, right? So there was this old technique called sample rank that we kind of dusted off and were able to reapply in a setting where we were actually doing Gibbs sampling atop of sort of a neural factor graph. And we were able to get sort of state-of-the-art results without contextualized embeddings. But the thing that I learned from this was just the sort of some of the nuances of how we could actually go sort of below that Python layer down into C++ and be jumping back and forth between CPU memory and GPU memory such that the Gibbs sampler could actually be blazing fast instead of super slow in Python. finite state transducers, I'm told that you all actually are forced to sit through at least one lecture in your curriculum that talks about finite state transducers, which is wonderful. They're possibly not as common these days because traditional WFSDs have basically a score per arc, right? And if you're used to building, say, RNN-LM or transformer-LM decoders, then you don't want to just have like one score per arc. You would rather have a score for a long sequence of decisions. And so we introduced this idea of neural finite state transducers where our NFST actually scores an entire path through the lattice of a finite state transducer. And then it's a better model, but then requires approximate inference. And so what we found with this model was that on the grapheme to phoneme problem and the phoneme to grapheme problem, we could apply something like a standard seek-to-seek model. And we could certainly also apply a very classic traditional sort of IBM Model 1 where we had basically neuralized it. So the actual scores for IBM Model 1 are computed by some neural net. Not very fancy, but kind of interesting. And then, but then what we found was that our NFST was kind of combining the best of both of these, right? It was imposing the sort of structural constraints that you were getting out of IBM Model 1 while also employing this super high parameter model like a seek-to-seek model. And not only that, it was better than sort of this other simpler idea of how to combine sort of neural methods with classical finite state methods. Okay, so for me, I had thought that I had already learned finite state transducers, and I kind of knew some of the textbook stuff, and that that sort of direction was closing, right? It was the kind of topic that just shouldn't really be taught anymore. And so this project was kind of eye-opening in the fact that it kind of brought back for me this realization that this classic topic was still relevant. With Maria, I've also worked on an unsupervised informal transliteration. And so here our goal was, given some transliterated, so I should give some context. So the idea is that if you have a Russian speaker and you hand them not the Cyrillic keyboard that they're used to, but your keyboard, and ask them to message a friend, they might actually be creative enough to use that Roman alphabet keyboard to write down something that is really not any sort of language that we would assign a name to, but rather it's some transliterated version of Cyrillic Russian into a different alphabet. And so the goal was, given that transliterated text, to learn a mapping back to the original orthography that was in the head of the person typing it at the time. And this also comes up in Arabic, wherein it's referred to as Arabizi. And the key thing that I could not have possibly seen in this was the kinds of patterns that were apparent to Maria as she was able to sift through hundreds of examples of this data. And because of that, she was able to pick out the fact that there were sort of similar visual and phonetic substitution patterns that were happening in the data, and we were able then to actually model that with priors, such that, jump ahead, such that adding these phonetic and visual priors, or a combination of the two, was actually approaching like a supervised level of performance, and was outperforming sort of a neural MT baseline. So most recently, I've been working with Amanda and Graham on perspective shift, wherein we had been thinking about how to do unsupervised summarization. And we started looking at a lot of dialogues and trying to come up with ways to actually break down the task of summarization. And so, here, the dialogue on the left, I guess it's kind of faint, but here we have this one statement like where Jack says, "Sounds great, mate, but I'm skint." And the idea of perspective shift was, what if we took every line in that dialogue and converted it to a third-person, sort of more formal version? And so that would be something like, Jack says, "That sounds great, but Jack is broke." Okay. So the interesting sort of aspect of this was realizing that that making this transformation we could actually think of as like sort of breaking up into a bunch of steps, and it was thinking about it as consisting of a bunch of steps like reframing, co-reference resolution, syntactic rephrasing, emotion attribution, and formalization that actually sort of allowed us to even come up with the task in the first place. And so it was sort of thanks to Amanda's thinking about how we could do unsupervised summarization that we were able to invent this new task. And so the fun part about this is that we can actually sort of employ extractive summarization on a perspective-shifted dialogue, right? So no longer do you actually have to rely on these sort of hallucination-prone abstractive summarizers. You can actually perspective shift first, so go from first to third person first on an utterance by utterance level, and then run a traditional extractive summarization system to get back something that avoids hallucination. Okay. So the last thing I think that's been really impactful for me in doing research over recent years has been external collaborators. And so I've had the good fortune of working on data that I couldn't have touched on my own, namely actual conversations between doctors and patients, and building abstractive summarization systems for that by collaborating with people at, well, first it was called M-Modal, now it's called 3M, now there's a spin-off called 3M HIS. Anyway, vaguely some company called 3M that you might have heard of. As well, there's this small business that's been collaborating with me on some sort of problems in noisy information extraction. And then most recently, sort of this collaboration with a brand new nonprofit that's the goal of which is to create a more racially and socioeconomically just housing market. And just sort of starting with that goal has led us to some really interesting problems around data imputation for housing data. And then sort of another ongoing collaboration with some very non-technical collaborators at the Pitt School of Medicine has been trying to sort of take some of the things that we've been doing on doctor-patient conversations and create an open access repository of sort of mock doctor-patient conversations. Okay. So to wrap this up, I figured I would come back to this conversation. So 6 years later, the conversation has sort of ended like this. Okay, Jason, for the record, 6.5 years in, I'm now thoroughly convinced that teaching and research is indeed the right combination. And I was fortunate to find the right balance of those two for me. And so I think that this is illustrative in two ways. One is that, gosh darn it, your advisor can still teach you things like 6 years later. You just can't go away. But also that, that there's this balance to be had. And the balance that's right for me might not be the balance that's right for you. But the balance for the person you're sitting next to might also be different. And you don't have to kind of get pigeonholed into sort of the particular combination of these things that pays you the most money, or that, that everybody seems to think you should be doing. And I think that, teaching helps ground us. Humans have struggles and gifts, and they don't always think the way, they're not machines, they don't always think the way a professor wants them to think, and I think that diversity could actually help us. It might help us with, designing technology that helps people to be actually more fully human. And on this point, I think, Robin Wall Kimmerer would probably agree with me, right? She writes that, there was a time when I teetered precariously with an awkward foot in each of two worlds, the scientific and the indigenous. But then I learned to fly, or at least try. It was the bees that showed me how to move between different flowers, to drink the nectar and gather pollen from both. It is this dance of cross-pollination that can produce a new species of knowledge, a new way of being in the world. So this is sort of, I think, her argument for a mutualism of scientific and indigenous knowledge, but I think that the same analogy that she's painting here applies to the mutualism of teaching and research. So I'll stop there. Thanks for joining, and I'm happy to take any questions. Yeah.
Could you talk about some tests, as you can call them, with teaching, with regards to gauging how well your students are learning, and things you did to test how much they were learning?
Yeah. So there's this entire, I would call it like a mildly failed research project that I didn't include in this talk, in which one of the things that we observed about teaching a 500-person course is that something that the instructor tends to be better than their TAs at is identifying how best to sort of get a struggling student unstuck. And I think that like a lot of that comes from just sort of the perspective of this repetitive teaching process, right? That like I've seen a lot of students like get really stuck or start failing on something, and some of them have made it, have turned around, and some of them haven't. And that sort of knowledge is maybe hard to impart to your TAs so that they could do it on your behalf. So we actually started building models that were trying to come up with like fine-grained pictures of what areas of the course students were excelling in and what they weren't. And to do so in ways that maybe even the students wouldn't be aware of. Things like identifying the fact that they were doing poorly on any questions that involved drawing, or that they were struggling on all the questions that seem to have an underlying requirement that some important stuff from geometry. And so I think that this is like one of the the spirit of that approach is actually like a really effective way of sort of testing what people know and don't know, basically to empower them with the ability to kind of like see where they're doing well and where they need to work harder. And in particular, to empower them with a picture of what other sort of fields and sources of knowledge you're building on, because I think that's often not apparent in most courses. So I think so I'll say why it was failed. It was probably the fact that it failed was primarily due to like our inability to like properly get this information out to them at the right times in a way that they could sort of make actionable changes. So we haven't yet figured that out, but I think that there's something about that idea that's still quite good. Yeah.
Do you think there are limits to how much the classroom or the educational experience should be measured and analyzed? I mean, you can imagine, the idea of trying to measure and track students within your own class and help them, but that could easily be expanded to measuring them across all their classes in MLD or all their classes in CMU, or even, if you had some data sharing program going back to undergrad, or tracking TAs, which kind of TAs work best with which students, or maybe which professors ended up having worse outcomes for something that could and should be scaled, even beyond just one classroom or one class?
Yeah, so I think that it has its place, right? So part of the project that I was just mentioning actually came out of a collaboration with someone at Duolingo, where at Duolingo, they're very wedded to the idea that data should drive the entire learning experience. Everything from the order in which the material is presented down to which material is presented. Whenever Burr Settles comes and gives a talk in LTI, he has to point out that the metric that they are optimizing for is user engagement, which sometimes translates to more learning, sometimes not. And so I think similarly, like the metrics that we use to evaluate things, like performance on an exam, aren't necessarily like always capturing what we want to capture. So I think that like these numerical sort of scientific methods in sort of improving education are really important up to the point that you recognize how broken many of our assessment tools are, which are often forming the basis of like what you might be optimizing for.
Yeah, I mean, you can imagine a situation where the thing you're optimizing for goes beyond classes, and
Yep.
say students say, okay, what I really want out of undergrad is I want to get a job as a software engineer, and then when they graduate, they say how many applications they sent, how many rejections they got, and you like look back and you try to predict like which professors and which classes led to
Yep.
students getting those offers. It seems to me kind of scary, but maybe.
So yeah, scary maybe, but I think Carolyn has actually worked on exactly this in the context of the largest online school. It's called Western Governors School, where she was thinking about how do you predict course sequences that are more likely to get people to graduate. And so here, like, I think as a loss function, like this is like in many ways like the right loss function, right? Like for Western Governors School, if the student can graduate, it's a huge win over them like getting halfway through and leaving and just like putting all this money on the table and not getting anything out of it. And so to the extent that like we could more effectively model a path that would be a sort of a personalized path to getting someone through to graduation, I think that like that's what a good advisor should be capable of doing. But under the constraints of time and many advisees, like they might not always do a great job. And if we could improve on the personal touch with a machine, I think that actually could be a good thing.
Thanks.
Yeah.
Hi, Matt. Thank you for your talk. Very interesting. And my question is like, for different people, they have different priorities. So when you have co-instructing situation, if the other people care less about teaching, or rather they may just need to care more about other things and they have limited time and energy, and how do you persuade them to like put more effort or whatever into teaching? For example, they may just want to reuse the slide they made last year, and then that may not be very good. You want them to improve it, but as a co-instructor, you can only make that much suggestion. Or just like if you cannot persuade them to make the change, how do you ensure the education quality for more students and still try to make the course better?
Yeah, this is a great question. Yeah, like so what do you do when co-instructing? So I think that MLD, more than other departments, has had a tradition of co-instructing. That's actually largely because Tom Mitchell was really behind this idea of co-instructing. And basically, I think that there's always like a great cost to co-instructing, which is like this disconnect between two people's views. And so even putting aside like, the number of hours that someone has available for the course, I think that like, even if both people are super invested, there's this great potential risk that the course will like sort of fracture in multiple directions. And whether it's just at the level of notation or whether it's like, some some higher philosophical level. I think in machine learning, it's actually often very much just at the level of notation. But I think that ultimately, like, this is like a coworker relationships question, and like I've been fortunate to have like some spectacular co-instructors, and even some of the busiest people who like I wouldn't have expected were actually some of my favorite people to teach with, and so I think that that one of the sort of possible solutions there is to think about like what are the things that co-instructing brings to the table that you can like actually make improve the course. And so it could be something small like Tom and I did this thing where at the end of every lecture you would just hand off to the other person. So if I had taught the lecture, we would just hand it off to the other person, and they would take the last 5 minutes of lecture. And they would get to talk about whatever they wanted, like whatever happened to be on their mind. And like this small change was immensely impactful because suddenly that other instructor is sort of forced to listen in on everything you say, or else those last 5 minutes, they're gonna look really silly because they don't know what you were saying. And further, it also brings in like like these just totally different perspectives on whatever the topic was, right? There might be something that the main instructor kind of missed that in those 5 minutes you can bring in a different viewpoint or a different application or something new. And so this was like a very simple idea that Tom came up with that I think like, at least in the context of lectures, made like a really big improvement to the lectures, even if we were maybe, I don't know, detracting from lectures in different ways, right? Yeah.
So you talked about your kind of shift from a transmission model of teaching to one where you facilitate students' own learning objectives.
Yep.
And I'm wondering how you think about the tension between the course structure and like the variance of student objectives here. Like how much latitude can or should there be, especially as you go on like later in a curriculum where the idea of like what you should learn from a graduate class becomes less defined.
Yeah. So this is a great question. I think that that a lot of times as an instructor, there's like what you want to do, and then there's what you actually do. And I think that on this point, like I'm often doing maybe not quite what I want to do, meaning that like to create many different paths for different students is a logistical nightmare. It causes all sorts of problems for grading and for managing, diverging paths through the course and so on and so forth. And so, I actually I think in theory, I'm a big fan of this idea, but have gone in my own teaching maybe very in the opposite direction towards like very rigid course structures that are very linear, sort of one path. And so I think that ultimately for graduate coursework, one of the things that I benefited enormously from being in sort of a smaller computer science department rather than like a massive SES kind of place was being forced to take these classes that were like completely outside my area, like a systems course and a randomized algorithms course, and these things that were like clearly not going to like immediately impact my research or the kinds of things that I was going to go build. But I guess I appreciated sort of being forced down that particular path because it like broadened my horizons. And I think that that's the maybe silver lining to not offering flexibility, is that sometimes it's actually okay to like bring everybody along for the ride and offer them something that maybe isn't exactly what they need, but could someday be useful. So, yeah. Yep.
Yeah, so obviously maybe we'll not one and then
Oh, yeah.
we can come up and
Yeah.
chat
Oh
about
yeah.
it.
You have snacks and stuff. So yeah.
Yeah,
Oh, sure. Last
yeah,
one.
I see you like mentioned tutoring as a way to encourage students to social to know each other.
Yep.
But in most of the time, like I think the students to know each other in the class. So what do you think is the efficient way for students to know each other? I think some professors will encourage group discussions. So like in the Zoom, they will create some like private room, like random rooms and random assign some students can. But whenever I enter that room, I can feel the silence in that room. So
Yeah.
I think this is not an efficient way to do, because students are more willing to discuss with other students they know, but not the student. So I think there should be is there a way that you encourage students?
Yeah, this is a great question. So your sentiment that Zoom breakout rooms are terrible for teaching resonates with me, and I think also with like various people over the pandemic who tried it at CMU. I would say, so the part of the reason that I think this peer tutoring thing worked was that it was, one, it was opt-in, two, it was randomized, and three, there was nothing about it that was tied to your grade. So the whole point was that we were putting people in groups with like the sole goal of like getting them to interact with people other than their friends, right? And so even to the extent that we wouldn't tell them this, but we would actually look at their department and sort of use their department to try to push them into groups such that the groups didn't like have a lot of departmental overlap, which might reduce the chance that they would sort of cross paths elsewhere. So I think that those are like more natural, basically like kind of moving the social interaction outside of like really rigid course boundaries was why I think that was successful, rather than like tying it to a homework or something like that, where I think it was like a really big failure. And I think lastly that, you know, lectures like, I spend a lot, I didn't really mention this, I spend a lot of time trying to make lectures interactive, but I also recognize that like lectures are very much like a tiny part of a course. It's just like, you know, it's like 2 80-minute things twice a week, you know. There's a lot, all of the time that you put into the course is really not in lecture. It's outside of lecture, or at least 90% of it is. And so, so creating systems that work well for that 90% of the time is more important. Yeah. Well, yeah. So we can stop there, I guess, and.
Yeah.